What we're going to be going over today is our Savvy software, specifically the SFD variant of the software, which is an upgrade from the base version. I'm just going to show you, in case you don't already have it, where you get the software from. If you go up to our website, driveweb.com, now I'm going to be running on a Macintosh, as you see here, but this is cross-platform, this software, so you can run on a Mac, a Windows platform, or a Linux platform, depending on your preference. And the way you get the software, I'm just going to turn on my little lasso feature here, is where you see this Get Savvy, click there. Regardless of the platform, that's where you'll click to actually go into the downloads page. So once you click that, you'll be prompted with a form to fill in screen. As you see here, normally you would fill the form in and we would email you a password to get to the next screen that would work from there on out. Now I'm going to go under the done this already and enter the password that you'll be emailed if you haven't already registered. And what you'll get to is the next page where you can actually download the software. Okay? Now I'm on a Macintosh, as you see here. If I click this link right in the middle of the page here, that would actually get me to start to download for the platform I'm on. Now I'll just do it just to show you what the file that it creates down in your downloads folder. Now for the Mac platform, you'll get a disk image once it's done here, a Savvy disk image, which you just put onto your desktop and install the software accordingly. Now there's also, if we go back to the page that we came into, you can click on one of the other downloads directly if you like. If you're on the Windows platform, when you click that same link, you'll see you get down here in the lower part a zip file called install or setup.exe. It actually extracted it for me. But it's a zip file, and when it gets extracted, there's a Windows setup.exe file to install the software on your computer. Now the SFD part we're going to be going over is geared around actually doing design work, so it has a signal flow diagram option turned on. Okay. And just to go back to the home page, just to give you a bit of overview if you're new to the technology. If we go down and look at this screen here at the top level, we're going to be working with Savvy SFD, as you see here on the left-hand side, and going through the entire process of how to actually drive the software. This DriveWeb technology can be used with this tool to connect our DC drives, our AC drives, and some intelligent devices we manufacture called a Smarty, which is this unit here, and a Speedy, as well as it can talk to iOS devices also, all through this Ethernet backbone that connects all this hardware together. We also have some new products, fairly new touchscreens that are shown up at the web page that if you're interested in, I think you've seen it with down in Charlotte with Greg's demo, is that you've actually seen the touchscreens, which you can navigate at your leisure with these Savvy panel touchscreens that you see down to the lower part of the screen here. Okay? We'll come back to this. The only other thing I wanted to point out while we're up here, sorry, it takes a little while to toggle between these modes. So when you're after you've downloaded and entered the password, I haven't saved it. So if we go down here, the one good thing to note is, in addition to all the other information, the Savvy release notes up here, they tell you when we release new versions of the software, which you see we just did in before the start of the new year. Now the software will, if you're on the internet when you launch the software, it will check our downloads page and it'll actually say, hey, there's a new version, do you want to go out and get it? And you're given the opportunity to download it or continue with your older version. I would recommend you, if you're going out to do a startup or anything, or just to start on the design, go ahead and get the latest and greatest. We're always backward compatible with our hardware, and you just don't want to have it to fight any bug fixes that may have already been addressed, or actually get some new features that may be available in the new software. So just stay up to date, effectively, what it boils down to. Now what I'm going to do is I'm going to launch Savvy on my desktop here. This is our splash screen, which is our wrench for our Savvy toolbox. And you see the first thing you're prompted for is a password. Now I've left all mine blank, which you can do if you're using your computer login to protect the software. But if you're sharing a computer among different groups but the same user ID, you may want to set the password like I'll show you here. So let me go back into demo mode. And if we go under here, under the capabilities, there's 4 levels of protection for the software itself. So Savvy has set for view, set for operate, engineer, administrate. So when you first install the software, you're prompted to enter in passwords. And so if you decide to put in passwords, then you'll need to remember those for the different levels of protection. If you're if you're the only one who uses your computer, I'd recommend you just leave it blank and toggle between the modes yourself, as I'll be doing today during this presentation. I can go from the administrate level to the view mode just by changing that one parameter without a password in there. Now it'll prompt you for a password when you go to a higher level, but since I left them blank, I can toggle between them at will. That's sort of geared around the people that share a computer in a maintenance shop or the like, so the right people will have access to the hardware. Now I'm going to load the demo devices just to show you how some of our navigation features work, so that you can always load what are called these demo phantoms, which they're built in and they actually pop up automatically when you're using the software once you first install it. Until you tell them to uncheck the box to load them, they'll pop in every time you get into the software. Now this is a fully functional drive web system with a DC drive, an AC drive, well actually 3 AC drives, a touchscreen, and a Smarty piece of hardware. Now these things are called phantoms because they're not real pieces of hardware that you can talk to. You can do design work with them. They're images of these devices, so you can do all your design work, but they aren't real pieces of hardware running a program. Now if I delete this just for a second, and I'll go ahead and use this file that's on my desktop, this demo internet devices. These are real pieces of hardware that are inside or actually on the internet. You see they're all locked. These are actually the same type of devices, except we've substituted a Speedy in lieu of a touchscreen to make it a little more usable. And these devices, if we dive into them, actually can run a program and actually perform. They interact with an application for iOS that we've developed, and they also can be used to demonstrate the hardware that we're going to be going over today. They're in our training room. Now I'm going to go ahead and delete these, and I'm manually manipulating what gets discovered. If the software can get to the hardware, even though you may not see it in the device directory like you see here, if you're set up your auto discovery, by default this is automatically turned on, and anything that it can find on your network will pop into your device directory. So even if you delete them, as I am here, you'll see they'll keep popping in there until you tell them stop discovering them by unchecking that box. Okay. Now, even though I only have 6 that look like they're local for me, if I go under the file command and say under the administrate mode, set IP address or system command you see there, when I select that, anything that is visible to my computer will show up in the list. So in addition to these 6 items you see here, a DC drive, a couple of Smarties, a couple of AC drives, and a touchscreen, if you scroll through here, all those ones, these ones in the back of the building here that start with the 10189 prefix, those are in the production area. They're on our network, but because of the way my computer's set up, I only see the devices that are in the 172.16 region. That's what all these addresses are. So the reason I've gotten to this particular screen is to show you the serial number that's on the devices, 04BB, and then some number after that in hexadecimal. Those are all assigned here at the factory when we build the hardware. So if you hover over one of these devices, like this drive on my desk, you can see across the top, it says 172.16.1.103, that's the IP address, and its serial number of the SPDY board that's fitted into it is 04BB000D11. And you see that's over on this list over here. So what was the number, 103? So 103 is right there. It's got our serial number and the IP address. Now when that comes in handy is when you're first setting your network up. Because you may have done all your design work ahead of time and you're ready to load your software, but this is how you can tell which device you're talking to by the serial number of the device, the hardware that's actually connecting it to Ethernet. A lot of times you'll see that referred to as the MAC ID. That's actually what the generic term is for that, but we use the MAC ID as our serial number. And the 04BB means it's something Bardak built. That's why it has that particular prefix. It's a registered address we use. Okay. Now I'm monitoring the chat window. If you have any questions, Stuart, just pop them in there. Okay. So I'm going to cancel this. We're just going to work with the info window will pop up at strategic times based on what I was doing. So even though these are the devices that it found and the serial numbers and the IP addresses, let's see, I canceled it, but if you had changed the IP addresses, it would record in this text window what actually happened for the session you're in with Savvy. Now you can save these and export them and import them with this command, the little blue control here. You can export them to a text file, email, or just print the entry depending on what you want to do. We'll get back to this at some other points along the way. Now let's just talk about navigation for a minute with our devices that we have presented in the window here. Now, if you want to zoom into a device or a window at any point, the plus equal sign on your keyboard will zoom in, okay? And the minus underscore key will zoom out to an extreme level, as you can see there. Now you hit the H key for home, it goes back to the default zoom level for the devices. In this case, this is the default size for a DC drive, some Smarties, and the screen you see there. Now you can present this device directory under the directory command. If you'd prefer to see it as a list, you can choose view as a list, and up pops a different window that has the same information, and that you've got the name of the device, the IP address, what type of device it is, but it also gives you how much memory you've consumed in the device without having to go in and do a get info and find out what what you've consumed. Some people prefer this. This was added somewhere along the line, and it's up to you which view you use. You just toggle between by checking the view list command. Okay. Now that once you've zoomed in, the panning around in any window, say I've zoomed in with the plus key a few times, you can use the arrow keys if you have an arrow keyboard, but the letters around the H for home are actually panning keys. So the G will pan to the left, the J will pan to the right, the Y will pan up, and the N will pan down. Now I'm going to hit the H key for home again, and you can also do 45s. A T will do a 45 up, a B will do a 45 down left, the M will do the others, and the U will be the others. So you can pan around once you're into a drawing or a trend or anything else we'll be going over today. You can use those panning keys at any time from your keyboard. We've also overloaded the navigation keys to the numeric keypad if you have it. So the plus minus add or subtract buttons on your numeric keypad will zoom in and out. The 5 is like the home key, and then the 7 would be like the T key. So all those numbers around the 5 are actually panning keys, depending on whether you're working on your desktop or on your notebook. And of course, the scroll arrows that are built into your keyboard still do their thing. Now, before I dive into the SFD level, let's just look at what we can do with the device real quick. So I'm going to move this over to the left a little bit. And if you notice when you hover over a device like I am here, you see how it's gotten, I'm going to zoom in so you can see it a little better. When you hover over a device like you see here, you see you get a gray box around the device, and that tells you that, hey, I'm selected, I can do different things. Now, this little down arrow here is like a right click. So if you don't have an easy way to go right click on your device you're using, you say you have a trackpad and you don't have a right click button or something along those lines, you can left click on this and up pops the context sensitive menu for any device that you're selecting on. Now, this menu will tell, as you go through, some of them are pretty straightforward. The get device info tells you, okay, this is the IP address of the device. It's a Smarty. Here's the firmware that's inside of it. All these things are shown just in the list that you see popping into that info window. Now, we only had one entry in that info window till now. So you see you can scroll back at any time until you close Savvy to previous versions of your info window with a timestamp. So until you close Savvy, you can save either individual things or you can save everything for your session before you leave Savvy if you wanted that text file to refer to later. Okay? And you always get to the info window under the window command. You can bring it up at any time. Now, some of the other things, the get detailed info, in addition to giving you the basic stuff, which is up top here, you also get information about whether it's set up for Savvy Panel, which is our operator interface scheme, how much memory. This is those little green bars that you see. If we go back to the other view of the direct device directory, this information related to the resource usage ties into the green you see here. So we're not using much in the way of, in this device, we're not using much in the way of, in 104, you see we're hardly a blip in the use of the unit because it's empty right now, which will change a little bit later. And this is the this is actually the consumption down here, how much memory you've used. Then these are the features that are built into the device based on how you ordered it. So this particular Smarty has the process control library, all the IOs capabilities, Savvy Panel, as well as Ethernet IP support, and Modbus TCP. This is what we call our 1121 option when you're ordering a Smarty with the basic software pack. And then more details that don't mean anything to the average user, but it's related to what release of the software is in there and what the timestamps are for everything. Okay. Now, if we go back to let's change back to the regular directory, and then let's look at a few more things in here before we go off and actually do something. Now, the other things we can do with a device, we can use, this is a real handy one, this thing called find parameter. Now, in any device, drive or Smarty, you can use the find parameter command. Now, in this DC drive, there are about 800 parameters related to motor control and the like, just in the drive itself. And say we wanted to look at the speed feedback of the drive, we can go under here and type speed and hit return, and you see a big window pops up with anything that has speed in its description. And it has what's called a parameter number to the left of it, which is a unique number that will never be duplicated in the device. Now we can change names in the device to support Savvy Panel. Like instead of speed error monitor, we can call that mismatch or whatever we want to call that particular parameter. But 125 will always be that actual data value. That's what the pin numbers are in the DC drive and the AC drive and all the Smarties for that matter. They'll all have their own address. Now, say I want to go to the speed feedback monitor. The little dart on the right side means it's on 6 different possible screens. Now, I may want to know that I want to see the speed loop in the DC drive so I can see how it's doing. So I select that out of the list and it jumps right to that particular parameter and it's centered in your window, the speed feedback monitor. Now, if I hit the H key here for home, I can see everything that's in there. Now, this drive is on my desk actually. It doesn't have 3-phase power on it, but it's actually doing something, which we'll get into a little later. Now, since I came from the device directory level, I want to mention these little navigation arrows up at the top. Now, if I want to go back to the previous screen, I just hit the back button just like a web browser. I want to go back to where I was. I can go back and forth through the whole chain of screens I've been in since I started. Okay. Now, if I go up a level, it goes to I go from the device level to the engineering screen. And if I keep going, I go to the device directory. Okay. So once they gray out, you can't go any further. So this tells me how I can go between different screens and navigation-wise. Okay. So we'll go back to the device directory and we'll look at a couple more things in here. Now, if I wanted to make a backup copy of this entire project, there's a way to just back up anything that's in your device directory for editing or just to take with you as a backup copy. Under the directory menu, there's a command called export data. Now, what pops up when you select that is it pops up with anything that's in your device directory. You see we got our 6 devices, and they're all checked to be exported by default. So I'm just going to put them onto my desktop here. And I'll just call this my first system. And I'll just export all 6 of these real quickly to my desktop. Now you see this file that I created right here that I'm shaking around. That's actually the file I just created. And that's an XML file that has all the programming and all those devices that you would need to replicate them if you had to replace some hardware. Now it's also something that can be used to edit your project in the hotel room or in your office. Once you've got that file in hand from either Phantoms or from the hardware itself, there's a command under the directory menu that we can import. Well, I got to turn off automatic setup so that it doesn't pop in unintended. Under the directory menu, I can say import data and create Phantoms. I can point to that file, my first system, say open, and it creates all my Phantoms for me. And now I'm ready to start working on the project the next day or in the hotel room or wherever you happen to be. This is an exact copy of what the real hardware had in it when we got started. We're going to go through the whole process towards the end of the session. So I just want to try to scoot through some of these topics so it makes a little sense later. Okay. So we'll delete those, and that's just, we'll keep that over here in case we want to restore our system to some level at some later time. Now, a couple other things. You can also, at the device level, you can export and import data. If you're changing one device, you can do test trials in a particular device. The hazard of that is if you have incoming and outgoing connections and you change them, you may get what's called unresolved connections if you don't restore it properly. So usually when you're doing experimentation, it's easier to, and especially if you're going to delete connections and replace them and that kind of thing, just back up your entire system. It doesn't take any longer than just doing one. But you have a choice to just do one device if you want to. As you go a little bit further down here, the text file, let's just do the DC drive because it's probably most useful in the organization of the 800 parameters you have. If you wanted to see all the parameters inside the drive, you can do a text file. And I'll just put this on my desktop so you can see what it looks like. And so any device, you can dump all the parameters out of it in a user legible format. So we just open that up once it's created. This is all the parameters as I scroll through all those about 800 parameters in the drive. And it's actually, you could set it up from scratch through the front panel if you had to. Now, anything you see with the little pound sign in any of these reports means it's changed from the default of the device. So the ones that have the little pound sign tell you, hey, these are the ones that actually got modified during commissioning. So there's this huge database in Savvy that looks at all the different frame sizes, all the different drives, Smarties and Speedies and everything, and it compares it to that database. And if the numbers changed or the connections or whatever, they show up in your report that tell you it's not at the default setting. So it's useful for troubleshooting purposes and support in general. Okay. Now we're about a half hour in, so I'm going to try to expedite these. We'll move through the last few things here. One of the cool features is this upgrade device selection down at the lowest level here, the lower down the list. And that device has everything. Let's see what this one does. So here we go. These have my drive has everything in it, so everything was grayed out and checked. But say you wanted to do a winder and a Smartie and you didn't have the winder feature built into it when you bought it from us, you can actually check that box and hit the OK button, and it actually puts that feature into our shopping cart, and then you just got to figure out how you're going to pay for it with a credit card, vouchers, which you buy from us. They're like Bardak bucks that you can use to redeem electronically for whatever you decided to pay. Whatever you decided to purchase. And then the offline via coupon is a way for us to turn it on in the field without an internet connection. The vouchers and the credit card, as you may expect, to redeem vouchers and credit cards, you have to be at least online long enough to get the coupon that is going to be applied to the device and turn on the feature you got there. So any of these software features that were in that list, when you do the upgrade device, if they're not checked, you can check them in the field and apply them without sending the hardware back to us, which is a useful feature support-wise. You can buy a bare bones Smartie and say you need a winder down the road. You can redeem your voucher or charge it on a credit card in the middle of the night if you got on a service call and actually do what you need to get done. Okay. That's pretty much it for this menu without going into too much more depth, and we got a lot to still cover. So we'll just, any questions, Stuart? You follow me okay? Okay, good. So what I'm going to do now is we're going to dive inside one of these devices. Let's just go inside this drive by clicking on it, and then we're going to talk a little bit about SFD now. Now the SFD program, when you aren't using SFD, you will see this kind of presentation of the DC drive. Now it's got every parameter in the drive. This is for if your customer doesn't need design capabilities and he just wants to monitor his drive, the free software will do everything he needs to do to support his hardware. The SFD upgrade, it's designed for integrators and people that may want to modify their system, provides a graphical interface to the design that you can use to generate a set of prints for your actual program, as well as to use it to diagnose the program by following the block diagram live while you're online with the module. Now this, if you have the SFD option, when you put this into your drive, let me just show you something like this DC drive we're looking at. If we go back to the home page and just look at the Speedies, let's just look at one piece of hardware. So in this DC drive, there's a Speedy just like you see down here. I'm going to lasso out. This is the board that gets added to the DC drive to make it drive web ready. It's called the DW221 Speedy. Now that board, once it's fitted, let me erase that and we'll go back to pointer mode. Once you've fit the drive web board into the drive, see this little divider that I'm moving on the left-hand side? Everything below this divider is built into the drive firmware. You don't need to, that's all. If you bought the drive, it's in there. Now, when you put the Speedy into the drive, it adds a new library of function blocks that you can add to the drive's block diagram. So it allows you to customize, even in a drive, what the solution is for what you're trying to accomplish. Now, if you go into the Smarty or the Speedy hardware, those are completely configurable. So this library of function blocks that you'll see that pop up when you're trying to place objects a little later, all those function blocks are based on what you purchase as far as the software goes. So what did you want to, when you go to our catalog and figure out what you want to do, hopefully it'll be straightforward, but with our help if need be, you can actually get all kinds of different things to solve pretty much any kind of solution in the industrial world, any kind of problem in the industrial world. Sorry, I got to get a drink of water. I've been talking too much. So this little divider is important in that this tells you where the blocks reside. It's not really important in the big scheme of things other than that if you were to pull that board out, if you stay native to the drive, everything would be below that line. Anything that you put into the board will be above this line. And that board actually has this drawing stored in it. So when you are working on a drive web system, and every device you have will have a copy of the prints in it if you used SFD to design it. So when you load the software, your drawings go in there and you can get them back out of there with an SFD capable computer, as long as they don't get clobbered by somebody else. Still, you always want to make backups, but it's a way to get that information back out if need be. Say you go to the hotel and you have a catastrophic or somebody steals your computer. As long as the equipment's still functional, you can get those drawings and everything that was in there back out of the hardware. Now there's a filter in this upper left-hand corner in the SFD, and this allows you to view that left-hand column in different ways. Okay. Now I'm going to leave it. Let's leave it like it is in all right now, and I'll just point to a few different things. This one over here that these double-headed arrow connections, those are the blue lines that are in your drawing. And you see some of them have white backgrounds and some of them have blue backgrounds. If they have white backgrounds, they're in your drawing already. If they have, so you see this ramp output let me drag it over, you can see the whole connection. So the ramp output to comparator 2, that's associated with this on the left-hand side. So that's coming back, that's this line here that we see that's got the input 1. If we right-click and remove from graphic that connection, you see it goes to a blue background. All right? When I drag it back in, it's actually brought back into the drawing, and now it goes back to the white background. Same for the function blocks. The function blocks that have a light blue background, like the stop mode ramp, they're not in the drawing, and when you take them back out, they'll go back to the light blue background. So anything that has a dark green tinge to it is in your drawing. Now in the DC drive, there are blocks that can be turned off, and they have this red X on them. So if you were to bring in this summer block, if you see it's red like that, it means it's not activated. Now you can drag things in the DC world to hook something up to them. There's nothing hooked up to this one. So what I'll do is I'll just drag it in, and when I connect it up to something, it activates the block. It's sort of peculiar to the DC drive, but that's sort of a legacy thing because this feature existed before DriveWeb was, actually made. The drive's about 17 years old now, as far as the vintage of the drive. If we delete that connection, it deactivates the block, and we remove it, it's back out of our drawing. Okay. Now, when you place a block that's you've placed in the DriveWeb world, if you right-click on white space over here, you get a list of the capabilities that, remember those capabilities we saw in the device info, well, the detailed info? These capabilities that you see here, okay? Mainly on this window that pops up, it's the process control library. I'll just put that down here so it'll be in the background. So these blocks that you see here are the ones that are included in the option 5 for the DriveWeb hardware. So they include arithmetic type devices, clamps, comparatives, control function blocks, all kinds of things you can browse at your leisure. And if you go under the add function block, you'll get a browser that sort of shows you, let's look at the control block. Say we want a PID. There's a block diagram for the PID. Okay, when you drop these blocks in, you'll have the block diagram in your library. If I hit OK now, there's my PID function block. Now you notice that went up to the top part on the left-hand side. That means it's on the board. Now as a user, you don't really care because you're just going to draw lines to connect things to things. So say I wanted this analog post connected to here, you just draw a line. But in the big scheme of things, the architecture is a little different in the background. So the slight difference in color just tells you where the platform is. Sort of like the break over on the side here. Okay? Delete the connection and delete the function block, and you see it goes out of the list. So that you can play with those filters any way you like. You can only show function blocks. You can show unplaced but active. You can do all these different things depending on what you're looking for. I'm going to hit the home key back for the home view on our, again, the H key for home. You use it in the drawing page as well as anywhere else. Now the drawing page that you create, you have a choice under the SFD menu to set the border to different sizes. So say I wanted 11 by 17, I can go under the set border and say, okay, make it ANSI B landscape, which is a standard size. Then I hit the home key, and now that's the aspect ratio if I have a printer that'll do 11 by 17 prints. You also have some European standards, the ISO, international standards in that choice, for the A4 and A3 levels, as well as some of our custom forms based on some different contributions along the way. I generally like these ones with the alternative title box because it gives you the most area to work with. If you go back to the some of the earlier ones and you choose them, you see the page, you get a corner of the page, and it doesn't make it as easy to lay your blocks out and do the drawing. So I've sort of changed over to the default as my ANSI A landscape mode. Hit the home key again. So that these zones that you see here around the perimeter, like the 1 through 4 and A through E, they're ways to locate where the blocks are when you start doing multi-page kind of things and breaks in your connections. Now, when you pick up a function block or you place one, let's just place a new one. We'll put in a PID block. So I'm going to go in and go into the control menu and put in a PID. Now, there's ways to, I'm going to zoom out from the title form. There's a lasso command. You see how this is all yellow. And when I let go of that, that selects everything that was inside my window. And these can be moved as a group, okay? Or you can do a subset of that. If you only wanted to do a part of it, you can move only some of them, okay? Now what I'm going to do now is if we go back to the home view, while these are selected, there's if you can see the corners, there's a little sepia tone square around the whole edges. And if I hover over this arrow in the upper right hand corner, I can actually increment by a page and drop these things all on a second page. Let me bring out some things here to show you how the forms work. So if I zoom in here, it broke the connections, but it points back to where those connections go to. Page 1, zone A2. Now, I could go to page 1 and go to zone A2, so that's a connection right there. Here's A2 down here. But I can also use these as navigation paths. So if I want to go back to the other end of this connection, I just click on it and it pops back to the other page. Okay? So you can go navigating around these links. Okay? But it does all this referencing for you dynamically as you break connections if you choose to do it. Now I can move this all back as a group to the first page. It'll deallocate the page. I hover over the upper left-hand corner, and you now see it reproduced all the connections back to my drawing. Now there's a shift command, or command I didn't mention when we were at the device directory level. Anywhere you want to zoom, instead of using the plus keys and zooming in and then panning around to where you want to go, there's a couple of different shortcuts to actually zoom in on what you want to zoom in on anything. If you right click and say start zoom marquee in any white space, that'll start a window that'll let you zoom in to whatever you select, and then the next time you click, it'll zoom into that window. Now that works fine for the average Joe, but you want to be a power user. The key is hold the shift key down and just click and drag. Okay? Then you can zoom in really quickly exactly where you want to be. I was just holding the shift while I click, and when I let go of my mouse, that's where it zooms to. So the shift, click, and drag, I'll try to announce it when I'm using it so it's not magic and sort of drive that home. Now when you're picking up function blocks, and if you go to the lower left-hand corner, it goes to the first page, and when you go to the lower right-hand corner, it goes to the last page. Instead of, you hover over here about a second, you get a page. You can see the page incrementing at the bottom. And so if I put this on page 6, I've got 6 pages to my drawing now with a bunch of blanks in between. Okay? So if I wanted to put these parts on that last page, I go to the lower right-hand corner, it jumps to the last page, and now it's on page 6 with that other block. There's a lot of pretty sophisticated editing tools built into the software that you can use to make your life easier. I'm going to put everything back on page 1 just by hovering. Now it remakes the connection. And once I drop them, I'll move this other block out of the way. Okay? Any questions, Stuart? Okay. So let's look at how we make a connection. Now there's a ton of function blocks. It's going to take a little bit of time to figure out, which blocks do what. There's a help manual that's built into the software that you can browse at any time. If you go under the user manual, that'll bring up it'll build a manual, and then from your software, then you can go browsing into different topics if you choose to, or if you want to say, I want to find out about the run mode ramps. If I do get function block info, up pops the information about this block. And if I do show user manual page, it'll actually jump to the info window that you see inside how the run mode ramps works. So there's all kinds of help built into the software. If you want to know anything about a particular parameter, you can just right click on it and say get the parameter info. It tells you what the parameter does, and then pretty much everything you ever wanted to know about it. There's info for everything, effectively. It's all built into the software. So let's look at how you make a connection between any blocks you decide to put into your program. So I'm gonna do create another viewer window so you can see. So this window is going to be inside my drive. Oops. Okay. So I'm going to create a new viewer. And right now it doesn't know what type of window I want. It said I just created a window. So under the file menu, I can say I can open another device directory, which will be just like the one we go up a level. It's the same device directory as you see here. But I'm going to go stay in the DC drive in this one, and I'll go into, I'm just going to change the name of this guy real quick to Tom Smarty. Okay. And then we're going to dive into that one on this page, which is an empty Smarty module. And I'm just going to drop one function block in there to give me something to hook up to. We'll see all the different ways to make connections. And I'll zoom in with the shift, click, and drag. And so there's a parameter. It's just a little place to make connections to, really. But it's used for a lot of other purposes along the way. So let's see how you make connections. So the easiest connections are in the same module. So I'm going to delete this connection here. And we're going to zoom in. Okay. And to make a connection, you see how the little circle pops up? I'm going to move this over so I can get it all at an extreme level. You see when that little circle appears, that means at the SFD level, I can get to the parameter I want to connect to, and I can just drag by clicking. You'll see a dotted blue line. And then when you get to where you can make a connection, you see sort of a reverse Pac-Man looking thing. You let go, and that makes the connection for you. That's how simple it is to make connections. That's the drag and drop method. Now you can do that locally, or you can do it across the network. Now this one's just a connection from a changeover switch to the ramp input. So say I want to connect this to my Smarty that's over in the other module. I think this is the, let's see if this is the one that has my analog input in it. It's terminal 16. Yeah, that's got my, I've got a potentiometer here. So this is my Smarty you see here, okay? So say I wanted to take this away, and I wanted to connect this analog pod to my DC drive over here. All I've got to do, let's zoom in so you can see what's going on over here. This is a connection across the network using the drag and drop. You start a connection on my potentiometer, drag it over to there, okay? And so let me bring them out to the top level so you can see them. So there's the ramp input. So when I change my pod on my Smarty, it's going across the network from the Smarty over to the drive for its speed reference. That's all there is to it, drag and drop between the 2 points. Okay? Now, if you hover over the little pentagon, which is the actual connection line, that's where it comes into the parameter. It'll tell you where it's coming from and where it's going to. Okay? Tom Smarty comes in and goes right to the output, and it comes into the ramp input. If you do a get parameter info, it'll tell you everything you want to know about the connection, both ends and how fast it's going. By default, it's a fairly slow speed, only 40 milliseconds, but I can change that. Both these things are ticking along at 5 milliseconds. If I want to change the sample period, I can say send it every 5. And now if you do a get info on that connection, you see I'm getting that parameter across the network every 5 milliseconds. Now you don't want to do that on everything, but the important signals, you can speed them up if need be to get the performance you're looking for. 40 milliseconds on a speed signal is plenty fast. But if you're load sharing 2 motors or the like, you may need to go on the 5 millisecond tick to get the data over there quicker. Okay? So that's the drag and drop method. Let's throw this connection away. You see it cleans up both ends like you see there. I'm going to put this one back in so it can keep doing its thing. And so the drag and drop, let's say we want to connect, let's see what another parameter is in here. Let's do the forward min speed. So anytime you see that little circle, instead of dragging like we were gonna do, we can right click on that parameter and say start the connection. Now it's on my mouse, so I can say make a connection here. Okay, and then I can go over here and say make a connection here. Okay, so until I reset that command, it's all of these are on my potentiometer, wherever that signal was. So it's a way to cascade from point to point. It's the same type of thing as a drag and drop, but it's a little more efficient depending on what you're doing. There's nothing special about the connection. It's identical to the other ones. And to delete them, you just right click and delete the connections. And then you don't have any connections anymore. Now, since I deleted that, this got left at wherever my pot was. So I can reset that back to the factory default. And everything's back to how it was. So that's the drag and drop as we've seen, the start finish. The final way to make a connection is right click and say connect to. Okay. Then anything in your device directory will pop up in your little window here. Now this is in, I know it's in the auto ramp drive, and then you get a list of all the parameters that don't have connections yet. So say I want to go back to crawl speed. If I look for number 41, there's crawl speed. I hit OK and it makes the same connection, just like it did before. Nothing special. It's the exact same as the other two, but sometimes that may be the easiest way to get to where you want to be. It's all up to you which method you use. A lot of people don't like to have a lot of windows open, so they'll choose one versus the other depending on what you're doing. So that's connections, how to make connections between either across the network or locally. You just drag and drop between your points and the connections will be present. Now, before I get into some of the details of configuration, we're about an hour in, so I need to get moving here. We'll just talk about parameters for a second. So all these blue things that you see in this program are all parameters. So the parameters, they can be manipulated directly if they don't have an incoming connection, but with this setter, so you can change values if you want. You can set them back to the factory defaults. Okay. Okay. So whenever you change a parameter, this little blue bar or brown bar will show up under a non-default value. It's used for our reporting features as well as a nice visual indicator that somebody's changed that parameter. And you can see them from a distance pretty easily. You see there's 4 parameters in this function block that have been modified along the way. And it looks like I changed these probably last time I was playing around with them. So they're some value. I'm going to put these back all at 5 because I didn't reload my program before. And we'll change them later. Okay. So this is actually, as we look over here to the right-hand side for the ramp output, this is actually a parameter that's changing in my DC drive continuously based on the program I built. It's just a little program that ramps it up and down from full speed positive to full speed negative continuously back and forth, which we'll see why in a few minutes. Now you see this little AC waveform in the background. That means it's an analog parameter. You see the ramping flag has a square waveform. That's a Boolean parameter. The little pencil with the line through it you see here, that means they're read-only, which makes sense because the drive's ramp function block takes care of controlling those parameters. So it's a function of the particular module you're in. You know, anything that's read-only is controlled by the hardware. In this case, all this stuff down in the lower right-hand corner is all, and the whole right side pretty much is all set by the drive because this function block resides in the drive. These little blue pentagons are incoming connections. You go up a level, those are all associated with the blue lines coming into the device or going out of the device. So when you go in, you see I've got the ramp input shown in my drawing. Now there is a connection down here, but it's if we go to unplaced connections, these are things that are not placed into the drawing. So you can find, if you want to go, this is jive mode select. If I put that in, you see it doesn't tell you where it is because it's not on the drawing, but it tells you where it comes from. That's what these blue pentagons are inside here. They're incoming connections, and these are outgoing connections. Okay? And you can navigate, like I said before, directly by just selecting where your path is. I want to go to, say, the filter. There's the ramp output coming into the filter block. Here's the filtered value, just to show you filter in the DC drive. Okay. So the analogs have an AC waveform. The digitals have a Boolean, or the Booleans have a binary waveform. The last type is an enumerated, which we see down here. The enumerated is more than the 2 of a Boolean, but not virtually infinite like an analog signal. So this has a certain number of possible states it can be in that tells us the mode of the drive. Now if you right click on the parameter and say give parameter info, up pops the parameter, the info window. So this tells you what the possible states are. So it depends when you're running a drive in real life. If you were reading parameter 168 on some third-party hardware, the number that coming back to you would tell you what mode you're in. That's sort of, so if I see a 6, I'm in slack speed. Now the text is used throughout DriveWeb, but when you get into interfacing, you may need to know all those details. Okay. So let's we're going to go into a commissioning phase here now. We're going to look at how you build screens to look at parameters. Then we're going to go through the whole process in the last 15 minutes or so. So once you've got your design done, whether it's a standalone device like this drive or a network groups as you see in the device directory here, there's some commissioning features that we built into the software called docs. And I'm just going to close this window. And we'll go into the file menu and say create a new viewer. Now this window doesn't know what type of window it is, but if I drag a parameter into it, it automatically becomes a doc. You see how that, it says it's a doc whatever, and I'm monitoring that parameter in that window. Okay. Now I can put other things in there by dragging, or I can just right click on parameters. Let's do this one. And since there's a doc open, it just plops it into that doc. Okay. So we got the ramp input, we got the 2 filters. Let's put this one in there. Okay. And then we got one more here. So here's our 5 parameters we want to monitor. Now I can look at the digital values like you see here. I'm going to make it much bigger so you can see what's going on. Let me get them lined up here. Okay, so here's our parameters we're actually monitoring. Now, the beauty of the doc is that I can, once I build these things, I can save them. So under the file command, I can save as, and I'm just going to call it my PL series trend. How about that? And we'll just put that onto the desktop. So that I can find it. Here's my trend I created. Now when I close that, it's not gone. I can reopen it here by double clicking on it. I can bring my trend up. Or you can use the command and just say open recent and get into that trend window. And there's my trend for review or to monitor now. Now the digital parameters are great in certain cases, but maybe you want to trend these over time. I'm going to build another doc, so I'm going to create another new window so I can keep the 2 docs separate. Then I'm going to dive in here and I'm going to drag these parameters over here. So we can interact with the doc in a second here without having the other program part open. And I'm just going to call this one, it's right by the default name now. If I closed it right now, I'd lose that information because I hadn't saved it yet. It'll squawk at you. But what I'm going to do is save it, and I'm going to Save this one on my desktop and called it my ramp times. Okay. So I can close this window back here. Here are my ramp times. We'll just put that in here. And so on this window over here, I can say under the dock menu, say show trend. And we actually have over time, hit the home key to zoom in at a bigger level. Let me just get as much space as I can. I got to minimize my little GoToMeeting thing over here. So now that's the trend over time of my parameters that I'm looking at in my drive on my desk. You can see they change the colors based on what's selected that I put in here in the order in which I placed them. Now we have controls over here that we can say I want to just see when the value changes. I can reduce the gain on the pink waveform so that when it goes plus or minus 100%, I can move that up here. Then the output waveform, which is the big one, excuse me, the ramp output, I can make that much smaller. And if we superimpose that by moving it over, you can see it's related to when that other one switches. It's sort of showing you the design I've got here. And then if we separate these other ones here, these are the filtered, that's the MOP output being clamped with the top being square as you see there, squared off. And then the other two are just different filter values depending on what you're looking at. Okay, they're filtered. You can see the lag that it put in to the ramp output based on the filters. Okay, now I can pause this dock if I hit the uncheck the run command. And now all those navigation features, the shift, click, and drag, I can zoom into and see exactly what was happening at this point in time. Now if I right click on that, I can say show trend point info, and it'll give me all the values when those two crossed. All the 5 things that are in my trend. Okay, with a timestamp from my computer. Of course, this is all getting buffered in the background. So when I turn it back on, you see that it's still trending. There's no discontinuities in my trend or anything, and it's happy to keep on trending whatever I put into my dock. Now the reason I put this other thing in there is so we can see how changing the ramp times change the way this dock looks. So I'm going to change some different numbers over here, depending on which way we're going. You see I'm affecting my waveform. I'm on one of the ramps I've changed. That's this one up over here. And it's all related to my ramp times that I set. And so you know, say this is your PID loop and you're looking at the performance of a dancer or something along those lines. You can have your terms over in the ramp times type dock with your PI terms, and derivative too, if you like, in the trim range. And this one over here is actually looking at the performance. Or if you're looking at speed loop tuning for that matter, anything you want to look at that you can get to in DriveWeb, which is pretty much everything, you can get into a trend window. Now one of the nice things about this, say I want to freeze it and then I want to print out a copy. And you don't have a printer handy, but you may do it later. Under the file menu, you can export this to an image file. I'll just say my trend and save it. And so this file that it just created is something I can save either for myself or to print out later that'll show how things were going at that point in time. Now, if I go back into run mode, I can also see we've been going for a few minutes here, but not that long. Now, the things that are changing continuously, like you see these last waveforms, those buffers could fill up because I made them change all the time. The other ones that don't change that often, they don't use as much of their buffers, so your time period's longer. You know, it's just the arbitrary buffers based on what you're looking at. Usually a few minutes will be fine in most cases of what you're looking at. And then you can always stop and restart. Now I'm going to pause this And we added a feature into the doc world. And under the doc menu, there's an export the data that's sampled or raw CSV. I'm going to use a sample because it's a little quicker. Call it my sampled data. And say save. So now this particular CSV file I can import to another program. After my XLX stops bouncing, we'll see the data actually as it got accumulated every 100 milliseconds. Now the reason it's a time-based thing is because sometimes your spreadsheets and the like, if you give them too much data, they'll just won't ever come back from trying to launch them. Just want to show you that you can actually look at this data. I'll just make it fit the columns. And then if I go under the chart command and say reproduce the lines, you got my chart. Now you don't have the controls we have in Savvy for scaling, but you see the raw data is reproduced back into something that I can use and print out or do any analysis on in this, in Excel or whatever program I have that can handle CSV files. Okay. Now we're about 15 minutes out from completing the session. Let me just, I'll save this to my desktop. I don't know where it went. It must have saved it back as a CSV file. But what I wanted to do now is to try to tie it all together by doing a quick design and troubleshooting of an entire Smarty. We'll just open up a blank Smarty and go through the whole process. Now I'm going to close this, not worry about saving the changes. Let's open the device directory. And we're going to use Tom's Smarty that you see here. Now remember this address, it's 1.104. It's 172.16.1.104. Okay, so I'm going to go in like the average guy. Don't worry about saving that. And I'm going to work offline, being prepared to load it into a Smarty. Say I'm in the middle of the night and I got to replace an old analog rack that did a PID function to get this machine back up and running. Got the Smarty in my toolkit, and I've got enough I/O to do what I need to do to replace that $30,000 rack that is obsolete now and has an 8-week delivery time. So let's just go from the starting point where, okay, now where do I start? First, I've got to create a phantom of a Smarty that I can use. I'm in the cafeteria drinking coffee while I build this thing before I go out and install it. So I'm going to go under the directory menu and I'm going to create a phantom device. This is the way phantom devices are those sepia-toned devices that allow you to do your design work separate from the hardware. So I'm going to create my phantom device, and it walks you through different menus. Now it's a drive web controller, which I know is my Smarty. It's a DW210, just because I've gotten familiar with the product. And it has our 1121 options in there, which are what you see here. None of the option cards that are available. And I know the address is going to be 104 because that's what I want to make it on my network. And if I hit the OK button, I get a blank slate. My Smarty, it looks like a Smarty, but it's empty. If I go diving into it, there's nothing in there. Okay. So let's say I want to make my drawing 11 by 17. So I go into the set border command and change it to ANSI B. Okay. Hit the H key for home, and now I'm back into that aspect ratio. Say I want to put a little bit of title block info in here. I'll go into the SFD menu and say set user attributes, and I'll say designed by Tom Curnow on today. We'll call it Groundhog just to not his honor. Okay. Issue A. I'm going to say it's a pre-release because I haven't tested it yet. Some number. Let's say 1, 2, 3, 4, 4, 5, 6. ME is our prefix for software in our world. So I'll say that's my number, and then said, we can put any notes we want, okay? Hit the OK button. You see it fills in the title block for me. Now, I can rename, anywhere I see this little picture of the drive, I can get the Speedy, I can use the context sensitive menu. So I'm going to change the name to, this is on an outfeed section, so I'm going to call it outfeed ref. Not just say outfeed. It's going to be controlling the outfeed section. And you see that changes the title block info, but the IP address is still down there in the lower right-hand corner. So now I got my blank slate. Now, you don't see this, but on my desktop, I have 4 potentiometers that I can use for my program so that we can actually look at them live. So the first one I'm going to drop under the I/O menu. I've got an analog pot tied into terminal 16 as an analog input. So I'm going to drop that guy in there. So this will be a pot when we go online, we'll be able to see that potentiometer. I've also got another one on terminal 13, another analog input. Now, if I want these blocks to be a little bigger, I can go into the SFD menu and change my border scale down to, let's say, 80%, and my blocks become bigger on the same page. Okay? So you get to change that all in one fell swoop if you need to. Now I'm going to drag and put another I/O block here. And let's put in terminal 14. That's good. Oops, wrong one. There's terminal 14. And the final one is terminal 15. I could have left that one. I already got 15. Oh, this is something that, you see how it was grayed out there. A lot of people that start out with this, they see that it's grayed out in the list. That means it's been picked. The thing is, I don't see it in my drawing. So I notice up here that I accidentally removed it from a graphic instead of deleting it. So I don't have to replace it. So if you see something like that when it's grayed out, it could be over in this left-hand, say I remove it from the graphic like you see here, and then you say place function blocks, you see it's out of the list. If you go to unplace function blocks, that's the only one that's not placed yet. So that filter comes in handy when you're trying to solve something that doesn't make sense because you didn't hit the right button accidentally. Okay, so here's our inputs for bringing in the real world, and we're going to have one output for the analog output. Let's just put it as a bipolar analog output on terminal 22. And this is let's label these so that we can see what they are. I'm going to zoom in over here with the shift, click, and drag. And I'm just going to change the name. I'm still going to leave the terminal 22 on there, but I'm going to say the outfeed speed ref. Okay? Hit the home button. So that's our right side coming out of the Smarty. On our left side, let's say this is going to be, whoops, wrong place. Rename the function block. And instead of terminal 16, it's going to be line speed. This is where our basic signal comes in. Say they got a dancer for a tension loop. We're going to make this terminal 13 be the dancer feedback. So we know the position of the dancer. Okay. And let's just use 14. We may use 15 later. We'll make 14 will be the tension enable signal because they're going to tell us when to turn on the tension loop. In fact, I'm going to change this type of block. So even though it's on terminal 14, I'm going to remove this. I'm actually going to delete it. And I'm going to actually put in a Boolean for our tension enable. So on terminal 15, not 14, we're going to use a digital input, and that'll be tension enable. It's still bringing voltage in, but it's going to act differently. It'll be a on or off versus an analog signal. Although you can do both. That's a long story. But so here's our basic blocks to interface with the old I/O that we had there. I use a lasso them all so I can move them as a group. Now, we could hook this directly up to there, but that doesn't give us any place to trim our signal. Now, you'll get familiar with these with different endeavors, but the thing I know that I'm going to use here is what's called a trim function block, which we see in our control menu. And what you see is what you get here. So if you go look at that block, I've got the line speed that'll pass straight through, and the summing junction, which I can enable and disable, will allow me to bring another signal in that I'm going to bring in from my PID. So I'm going to hit the home key. And let's just use a drag and drop connection locally, okay? And we'll connect this one up to here. And we got so right now, with what you see there, I would get my signal over to my outfeed drive section from line speed directly, except I put it in the wrong input. Should have left that for our own posterity. I meant to put it there. I'll make some mistakes along the way just so we can troubleshoot with our features once we load it in. And let's put in our PID. Okay, so here's our PID function block. Now we're going to put this into the feedback for the dancer. Okay. Now if you dive in here, it's just what you see. Here's the feedback right there, the dancer feedback. The set point's going to be a fixed value, but instead of diving in here and setting it in every time, that's something I want at the top level. So if I shift, click, and drag so I can zoom in, whenever you're making you want to see something at the top level, you pretend you're making a connection, then you hold down the control key and let go of your mouse and it brings it out to the top level. Excuse me one second. Sorry, my throat's getting a little dry. So there's our set point. We're going to put that at the 50% position so that the dancer rides in the middle. Oops. Back to the home view. Now, so this will be our dancer. This is the set point that we're comparing it to. Then all we got to do is hook our PID block up to here. All right. Now that'll give us our trim to keep the dancer in the middle based on the speed of the outfeed, to pull it up or let it go down depending on which way you want it to go. Now, if you hover over any of these lines, I don't know if you can see across the top, it tells me what that is. That's the PID integral enable. This particular one's the integral hold. This particular one over here is a PID enable. So that's the one I want to take my tension enable into, the PID enable. Okay? That's sort of the basics. Let's load this in and see if we can get anything working. I'm going to do a couple of things to make our trending a little easier. Excuse me. I'm going to put a little indicator block in here under the utility command. That'll tell me when the PID is on. This will go green when that switch is on. Okay. Now that looks pretty good starting point. I'll bring some other things out to the top level by pretending I'm bringing them out to this level. Okay. And let's save this so that we can load it in a minute. So I'm going to go right click on this device and export data, and I'll call my outfeed Rev A. Just put it on my desktop. So there's my program I just created in the Phantom right here. Okay. Now I'm going to throw away my copy of my Phantom, go out and plug into the real machine. Now, I could go discover the device. I'm just going to type in the IP address because I know what it is. So we're only looking at the one device. So I'm going to type in 172.16.1.104. Up pops my little Smarty, which may have some, we just left a few blocks in there, nothing important. So what I'm going to do is load this program over here into this Smarty by doing the reverse of the export, which is the import. Okay? Going to point to the file, hit the open button. It knows the right IP address because I knew that ahead of time. Hit OK, and there's our program loaded into the Smarty. Now we can edit online and make this thing work with our trending and everything else. Okay, so let's see if anything comes out over here. Oh, look, there's a value there. So here's my line speed signal. So hey, my line speed works coming in here. So I'm going to rename this thing instead of input that doesn't mean anything. I'm going to say outfeed speed reference. I'm just going to call it outfeed ref. Okay. And I know I'm going to want to trend that, so I'm going to add that to a doc, which will be where all this stuff's going to be going. We'll leave that over to the side for now. So any parameter, if you want to start a doc, you don't have to open a blank window. You can just say add to a doc, and if there's none open, it'll create the window for you. So let's look at something else. Let's put this this parameter into our doc. Just drag that over. That's going to be line speed. So we're going to rename that line speed. Okay. And so if we look at this trend over here, okay, there's our line speed. And we can see if I change speed up and down, let me take the green up because he's line speed. You can see it follows 1 to 1, right? So we're halfway home now. Let's make this, move it up a little bit. We'll just move this one up too. We need a little room for some of this other stuff. So now we got the line speed part figured out. So let's see, let's take the tension enable signal. We'll use this one over here, which is PID enable, and we'll just add that to the parameter doc. Okay. Now I'm going to move, so this is our PID enable. So when I move, I forgot what input that was on, terminal 14. When I move that value up and down, it's not enabling. I'm moving it, but you can't really see that I'm moving it, but it's not changing state. So let's dive in to that function block. Well, then my voltage is changing, but look, I made a mistake. It's not 24 volts since it's a potentiometer. I've got to be 5 volts because it goes only from 0 to 10 volts. Now if we look back here, oh look, now my PID enable works. Okay. Now that's a Boolean, so let's take that make it a little runt here so we can just see when the PID turns on. We can leave it at the 0 mark, that's probably fine. All right, we sorted that out. Now my little indicator should turn on when I get it on and off. See down here? My green indicator when it's enabled and when it's not enabled. And you can see, maybe you can see, let me zoom in. When it gets enabled and disabled, you see that it's animated at the SFD level, what's going on. It throws the switch to say the PID is going out to the output. And you see that it comes out of the 0 value for the integrator and goes back to integrating. If you dive in, you'll see the same animations. You see how your block is working, okay? So let's see. We've got our, let's rename this parameter. And this is going to be dancer position instead of output. We'll just call this dancer position, okay? We can just put an apostrophe in there to abbreviate it. And so we want to put that to the dock. Let's put that into the dock so we can see where the dancer's going. Okay. Okay, so if we look at it now, there's a dancer position. Okay. Let's put one other thing in there. Let's put the PID output. So now we got PID output. So we would expect when this thing is enabled, let's go down with the, make this a little bigger. Okay, and let's take the PID output down and take the dancer position up. Now here's our dancer position value. That's the range it's going to value. Okay, I can give it a little bit more. I'll just change the gain a little bit so we can see what's going on there. So let's put it in the middle position, and let's turn our PID on. Okay, I see it's slowly integrating up to the full output because my position is off a little bit from 50%. Let me go towards 50 and let it settle out. So my dancer is almost equal to my set point. The integrator will make it climb slowly. But look, I'm not seeing, if I change the line speed, it doesn't do anything. It's not changing speed. It's exactly at line speed. So I've forgotten to do something back here in my drawing. So let's see what's wrong. Now I've got my enable signal. It goes here. Now if we look over here real closely, there's a switch on this that's not getting thrown. Okay. Oh, so well, you know what? I just want to take this over to here to get that switch thrown. Now let's see what happens. Now we see, based on our trim signal of 10% with a positive sign, and this thing is integrating, so it's only 25% of 10%, but you see the outfeed speed reference is slowly increasing based on the PID trim. So now if I make it a drastic change, you see it moves quicker. And we can do crazy things. Let's just change the gain. This is where you may want another dock. Let's do another dock over here. Now if I just said add the dock, it would put it into this dock because that's the one unnamed one that's open now. If I go on and create a new viewer, let's just put the ones we want over here. So we'll do proportional, integral. Okay. We will not won't worry about derivative for right now. And we may want to have, let's get the trim range in there too. Maybe even the direction. Okay. So we can close this window now, and let's look at the performance. See, we've already integrated to full. We're at full minus output on the PID. So I'm going to reset the PID by taking my terminal 14 back to 0. You see we came right back to line speed. Now if we re-enable it, you see we jump pretty quickly because the integrator didn't wind down too much, and now we're integrating back up. Now let's do this. Let's change our dancer position back to somewhere in the middle. And then we'll re-enable the PID. And you see it's below the set point of 50%, so it's slowly incrementing up. And let's change the tuning parameter to, I don't know, let's make it 10, see how quickly it changes. Boom, it just changes really quickly. So there's our step change. So now when we got way too much gain in there because our PID is going crazy. So we say, maybe I'll put this at 0.1. And now you see it's a lot more forgiving. So that's it from start to finish of a little PID example.